Yes. So we are Team Hexcore, and I am its team leader Anurag Sharma, and I'm going to give you a brief overview of our prototype that we have built for the problems. Following problem statement. The problem statement ID is 25099, and the problem statement title is AI-powered monitoring of crop health, soil condition, and pest risk using multispectral and hyperspectral imaging and sensor data. And it's a problem given by MathWorks India Private Limited, which has made MATLAB itself. So we are supposed to use MATLAB tools, and we have used them. So yeah, we have used their hyperspectral image processing data tool, and also their app designed it tool as well. So yeah, let's begin. So yeah, I would like to welcome you to AgriFlux, a smart agricultural intelligence platform that transforms farming through satellite imagery and AI. Today, I am going to show you how farmers can monitor crop health, predict risks, and optimize yield using real-time data from space. So, yeah, before we start, let's assume you are a farmer who owns six different plots in Ludhiana, and you want to monitor their, their pest risks, or is the irrigation kind of low, you need to water it more and stuff, or like if are your plants under stress due to a recent flood, you can monitor and decide what to do, like what your course of action is going to be through agriflux. So yeah, it uses AI powered insights for precision agriculture. It has early warning systems for pest disease and drought risks. It has an interactive dashboard, and it also supports real time crop monitoring as well. So yeah, you can see there is a sidebar navigation, and there's the branding for agriflux. And yeah, so let's start with the overview page. Okay, agriflux overview. So yeah, wait a second. So yeah, firstly there are four metrics on the top. The first one is active field. So like I have five fields right now, which covers a total area of 1,247 hectare. And out of the five, there are four healthy zones, which is the same as yesterday. Like you can see, it's also taking care of time series data as well. You can see the average temperature of the land, the soil moisture, the yield forecast as well. It has smart alert system, there's three less from yesterday. Now it means it's predicting that you have a pest risk, or and your particular field needs an irrigation. Also, there's a health index, which is like the overall vegetation health index of 0.72 here, which is very good. This combines indexes like NDVI, SAVI, and other vegetation indexes that are commonly used in remote sensing. And data quality means 94% means that our remote sensing system is working really good. I will come to that part later because it's talking about the cloud masking stuff. So yeah, let's move on. Okay, so yes, currently we are on the overview page. It's the main dashboard for quick insights and key performance indicators. There are also other pages like for field monitoring, which is going to show you interactive maps with vegetation health overlays, field boundaries, and real-time sensor data integration. There is the temporal analysis, a page which is going to provide time series charts showing how vegetation health changes over growing seasons, helping predict optimal harvest timing. There is the alert and notifications tab, which is going to provide early warnings for crop stress, pest outbreak, disease risks, and irrigation needs, all powered by AI analysis of satellite and weather data. And you can also export your data that you have to because it is going to help farmers and other researchers for like generating custom analytics and integrating them with existing farm management systems or making new stuff. So yeah, this is a good part I believe that we can export our data. And yeah, now so yeah, let's go through each page I guess first. So yeah, this is the agricultural overview. You can see the vegetation health summary from a bar graph here, and yeah, like it's an overall overview which you can see. Okay, so yeah, let's now move on to the field monitoring area. So as you can see here, this is our area of interest, in which our satellite is going to work, and these are my 5 farmlands, and I can see like what risk on the alert I'm getting from each field. Okay, so in this Khanna district fields, NDVI is 0.63, and there is a vegetation stress, and that's bad, I guess. No, not guess, like it's bad. NDVI below 0.7 is bad. NDVI here is 0.85. It's showing dark green color. That means the crops are perfectly healthy, like nearly perfect. Like there's nothing much to worry about. Here is an irrigation alert, like we need to water our crops more. And it's an interactive map. We can also use Google Maps in the future for better stuff. There are many ways we can, like many type of maps which we can use here. Okay, like we can also use satellite map, terrain map. See, okay, my bad. Terrain map API is not working right now. No problem. There's also then OpenStreetMap, which is a Python, like usually used in Python, and it looks like this only. Okay, now it's time to move to temporal analysis. So yeah, temporal analysis temporal analysis provides time series charts showing how vegetation health changes over growing seasons, helping predict optimal harvesting timing and stuff. So as you can see, we can see the different stats of like random field, like North field A, South field B, the average NDVI over the last season. There is a trend, like you can see that the time series trends over there as well. And you can see we have made these graphs as well to like see what the vegetation index trends with confidence intervals. And it's we have used matplot library for, but not matplot library. We have used MATLAB for this. And yeah, it's like a MATLAB API here right now, which is showing this. So, yeah, that's the network integration they have asked for. We can also compare zone here with box plots for the last 30 days for NDVI and SAVI as well. And we can also export trend analysis. When you look at that, it has been exported into a CSV file. And that this is the most important part. It's the alert and notification system. So like for like we can here monitor and manage active alert system notifications as well. For example, in central plotty, there is a high vegetation stress because the NDVI is very less. And it has also given a recommendation to increase irrigation and check for pest activity. We can view the trends here. Or if say the AI system is wrong, you can also dismiss it, and it's also going to go back to our central database, and we can update accordingly. We can update our models. You can see there is a pest risk on South Field B. We should apply preventive pest control measures. There's an irrigation problem here. It's good. Monitor for fungal disease symptoms, and yeah, stuff like that. It's good. You can also see the alert trends over time. Like we can make more stuff also there. Or like yeah, we have notification settings as well when we want notification and how. There are alert filters as well here. And alert analytics, you can see response time kya hai and alert patterns kya rehte hain and stuff. Also, at last, we can also export the data as well, because time we are like mostly depending on time series stuff. So yeah, it's good to have a way to export and preview data. And also, you can see system health. Right now, we don't have any actual sensor working in the fields, and I personally don't know how IoT works actually and how to create those devices. So yeah, like for now, we are focused like taking the help of satellite data, AI models, and existing databases, and synthetically generated sensor data. And you can, it's like pretty much quite heavy, I guess. And let's say I am a farmer, I don't know what the hell is NDVI. So for them, we have created a help and documentation section as well. So yeah, getting started and understanding vegetation health, what range of NDVI means if the crop is healthy or not, how the smart alert system works, and you can support us. Like there are support resources, you can get help, and there are learning resources as well, which we will be rolling out in the future. And yeah, this is our code base at GitHub, and This is our deployable. Yeah, wait a second. Yeah. And so this is our deployable file that we have deployed on Streamlit Cloud. It doesn't have a database connection proper, and it also doesn't have proper APIs right now because that needs money, that needs capital, that needs infrastructure, which we don't have. The prototype version you saw earlier has been hosted on my computer locally, but yeah, it is still a good prototype for you people. And yeah, the best thing about the Streamlit stuff is that it also works on mobiles as well. There is no need to work or care like ये दिक्कत पड़ेगा ये वो मोबाइल में काम करेगा नहीं मैं तो किसान हूँ मेरे को मोबाइल ही चाहिए ये वो मैं पीसी नहीं रखता ये वो तो लाइक इट वर्क्स इट्स डिवाइस agnostic so there is no need to worry about that. So yeah, that is it from my side. But before we end, before we end, agriflux represents the future of agriculture, where satellite technology, artificial intelligence, and agricultural expertise combine to help farmers make better decisions and increase yields and farm more sustainably. It's a scalable solution with global applicability, continuous innovation, and a farm-centric design. It is built for practical and everyday use for agriculture experts or even your local farmer, which has a mobile phone with an internet. So yeah, about the technical architecture, yeah, let's talk about that in the presentation itself. Thanks.